Hello everyone, welcome back to another video in the LLMs related playlist. In this video, I'm going to show you all about the latest model Llama 3, which is the best open source model right now, even which beats Mistral with ease. It has a lot of benefits in it, and in this video, I'll show about what is Llama 3 all about. I'll explain the blog, each and every bit, and then I'll also show you how you can fine tune the model. I'll give a small walkthrough of the model's architecture in here, and finally we'll also test it with some real case questions by using LeetCode. Okay, all will be done, and I'll also say some of my assumptions of why this could be better than Mistral. Okay, all will be done in this video. So let's jump into the video right now, starting with let us know what is Llama 3 all about. Okay, Llama 3 is the most capable openly available LLM up to date. Yes, it is true. Takeaways is that they are introducing Meta Llama 3, which is the next generation model. It will be soon available, they have said, but it is available right now. And they have given more focus to responsible AI development, like to avoid any like harmful content, to avoid harmful content. They have developed Llama 3 in a responsible way. For that, they have taken a lot of effort, to be honest, and I'll also say what they have done for that. Okay, and in the coming months they have said that they will release additional sizes model. Probably I'm expecting some smaller and larger size model, and there is one bigger model which you won't expect to come out of Meta. To know about what it is, stay till the end, and right now you can also make a prediction in comment section and check it out if you are right. Okay, so they are introducing Llama Guard 2 Code Shield. These will all help for responsible AI development. Okay, but I'm more interested on this one, longer context window and the additional model sizes. Okay, this is what I'm interested in more. And today they are releasing two models, which is 8 billion and 70 billion. And they have said that, like, okay, we have given to the community and it's upon you to take this forward. Okay, and upon their goals for Llama 3, they are saying that it is to make multilingual, have larger context, and then improve the overall performance on the core LLM capabilities. Because I more focus on the reasoning capability, because if you are good with reasoning, you can be fine-tuned to do any task. Okay, the main capability which I see in a model is to do reasoning, and seems like Llama 3 or Meta organization is working in the correct way, focusing on reasoning. Now is where things get spicy. State of the art performance. 8 billion model and 70 billion model has a major leap. It is very honest, guys. Llama 2 can't even come close to Llama 3, and the improvements are such that now you can see, yes, it is an 88 billion model and Mistral 7B Instruct. Okay, both all are Instruct models, which is like instruction tuned models, but the difference is too high. Here you can see in MMLU it is 58.4 and it's 68.4 here. And in case of coding, which is human eval, these two doesn't even come close to Meta Llama 3, which is having 62.2. And here, like, if you add these two only, it would be even coming close. And same goes for GSM, which means it has a lot of good reasoning capability. Because see, when a model does well in math and coding, it indirectly means that, or it implies that it has a very good reasoning capability, and I love about that. So I think that is a tick mark for Llama 3 model. Okay, and here there is another thing which also interested me a lot. This is the 70 billion parameter model, which is the higher variant, and it competes with Gemini Pro 1.5 and Claude 3 Sonnet, and it is giving very good performance actually. Here you can see the MMLU is 82, GPQA is not so good. Probably they will work on that. Human eval is 81.7, GSM 8K is 93, and math is around 50.4, which is all good actually for a 70 billion model. Probably they will do some improvement at the later half, I'm expecting, but yeah, still it is a very good model, because these two are not open source, right? These are closed source, but this is an open source model, which means you can use. And I'm expecting the same Llama to community agreement to stay. I don't think they will give free license. I have not checked the license, to be honest with you, but I'm expecting the same, because same happened with Llama 2 as well. Now, coming on to the development side of Llama 3, what they did was they built an evaluation set, which is a high quality evaluation set, focusing on 12 key use cases: advice, brainstorming, classification, close question answering, which means like, context will be given and then question answer. Question will be given, answer is expected out of a model. Coding, creative writing, extraction, inhibiting a character or persona, which is role play, and open question answering, which means like, where does the sun rise, something like that. And reasoning, rewriting, and summarization, whatever is the core task, everything is covered, and then they evaluated on it, it seems. And in this evaluation, what happened was, this model, this is like, win rate, and how many samples Meta Llama 3 got better result than the other model, or how many they gave the same, and how many the other model outperformed. That is what happens with this. Win means better, loss means lesser performance in that. In every scenario, Mistral Medium, I was surprised to be I was surprised, to be honest with you, when I saw Mistral Medium actually, because still now Mistral large parameter isn't said yet out, and I'm expecting, there is again, like I said, one model is coming up soon, and I'm expecting that model to outperform and blow every other model out of the water. And as far as the pre-trained model performance is concerned, this is where, like I said, I have some assumptions here. Mistral 8x22b, which is the most recent model, and we all saw how much it is good in leaderboard, right? Still, it outperformed those as well actually. 77.7, here it is 79.5, 61.2, 63.0. In every place, approximately 2, if you want to say. But still, I'll use Mixtral in this case, because for the only reason that here, if it is 22 billion, right? 22, which is 44, and then probably another 1 or 2 billion for router, it will be 45 billion active parameters, and here it is 70 billion. For 25 billion parameters, I won't go for just 2% accuracy, but probably once they, fine tune it, probably it will be better. Now, to make my assumption, you can see this one. The measured one they had was 63.9 for Mistral, and they got 66.6, 44, 45.9, 56, 61. Everywhere it is very close, there is not a lot of difference. But why was there was so much difference here? This is where my assumption comes into the picture, where they built a very good data set for instruction tuning. Okay, I have always said that Mistral is so good because they did a very good construction of data set, because there is not a lot of innovation in their architecture actually, which will be the case with Llama 2 as well. When I show you the code, you will understand. But why they performed very well was the data set should be so good actually. And as far as the architecture is concerned, like I said, nothing new. They are using group query attention, which is the same used in Mistral as well. Okay, and they have a vocabulary of 128k tokens, and the sequence length is 8192. I'm expecting them to increase, like they said, I'm expecting them to increase, but still with rope it should be slightly higher. You can still fine tune for it, but I'm expecting that to come soon. Okay, this is where things are very important. To train the best small language model, they said, they understood that, okay, we need to invest on data, and they trained on 15 trillion tokens. That is pretty huge, and they're all publicly available sources. That is what impresses me a lot. And they have also focused on other languages with 5%. And like I said, they are mainly focusing on this responsible AI. So they made some heuristic filters, NSFW, content being filtered, semantic deduplication approaches, text classifiers to predict data quality. So they have employed a lot of importance towards data quality, and they use Llama 2 to generate training data for text quality classifiers, it seems. Okay, so in pre-training scaling up, they have said like how they have scaled up for this much large pre-training, because 15 trillion token is too high, right? So how they did that was explained, which is not necessary for us. If you're interested, you can just come and check it out. Which we are more interested is in the instruction tuning, where what they did was post training they made a combination of supervised fine tuning, PPO, and DPO. They combined both PPO and DPO. It seems, I don't know how they did it, because the training script is not provided. If they provide the training script, we'll also make fine tuning based on that. Okay, but that should be one of the reason why this is performing very well, along with the data again, like I said. And if you wanna build with Llama 3, like with the responsibility AI approach, you will be giving an user input. The input safeguard will adapt the input prompt with other information being filtered out of it, and the model will generate as usual. And there will be again an output safeguard to rectify whatever, like, if there is an harmful content in there which shouldn't be responded. So they have also tested that with the red team and all. Probably I'm expecting that is also coming up very soon. To deploy Llama 3 at scale, they have said that they will provide with a lot of API providers very soon. And since they are using GQA, group query attention, it has cost them to use token efficiently more than 15% than Llama 2. Because, like, I was not a fan of multi-query attention from the first. And I'm very happy they moved towards group query attention. This is where, like I said, the most important thing. Please see this. 400 billion parameters. See, I was skeptical when even they said, when Grok from Musk announced that they are launching a 300 odd billion parameter model, and the comparison was not so good actually. It was still just higher than 70 billion model, but this one is pretty good actually. Here you can see the instruct model has 86.1, 57.8, 94.1, 84.1, 48.0. But I hope this will increase, because they have said it is still training, and you can't see a lot of difference between the 70 and this one. Here you can see, right? It is 79.5. Yes, there is a big increase there. Let's go in. Yeah. 82, 94, 39. It was something different, but you get my point, right? There is not a lot of difference. 50, 53 or 59 something. Okay. So will I use it? I don't know. To be honest with you, I don't know. But if they even push this even harder, like something like MMLU to 95, GPQA to 60, something like that, once they train it longer time, right? Probably I might use it. Okay. And if you wanna use MetaLlama today, watch this video. You are in the right place. Okay. Now that we know what is Llama 3 all about, first I'll do the testing to show you the potential of Llama 3, and then we'll see how we can fine tune, and then we'll see how we can move on to the next. Here you can see there are top 100 liked questions, and I tried one question which is twosome. It gave a correct answer. So what I'm gonna do is, let's start with a hard problem, and then we'll go for a medium problem if the hard problem fails. Okay, so what I'm gonna do is, I'm just gonna copy these, Control C. Here I have created normal assistant, like you can just create. Okay, click settings and click create new assistant, and click your model name here. Here it is Meta Llama 3 70 billion instruct, and give a system prompt if you want. I just give space. Okay, it is upon you completely. This is my assistant with Meta Llama 3 instruct. What I'm gonna do is, I'm gonna ask a question. Solve this LeetCode question in Python. So what we'll do is, we'll just get this solution and we'll put it there. Okay, let's see if it is working. I'm not sure, because see, the acceptance rate is like very less, 30% at the first attempt. Okay, so I'm hoping it would fail. I will just copy this. Is it same num1? It is same actually. Find mean sorted array. Okay, I hope this should work. First, let's see if it is working correctly. It is working actually. Okay, let's try to submit. What? It has beat 84.58% users. This is pretty amazing actually. I'll be honest with you, I didn't expect this good result from Llama 3. it is solving very good LeetCode questions. Yes, I'm again being skeptical. Like, probably they could have even trained with LeetCode questions, but still, this is a very good performance, actually. Like, you can see my honest reaction. Like, I didn't expect that to, like, give this good result. I was expecting it to give a result which will work, but probably, like somewhere here or here, like, better than 10%, 20%, something like that. Giving a best result possible, like, this is very good model. Like, I didn't expect this good model, actually. Yes, it is a 70 billion model, I accept that, but it is a pretty good model, actually. So what we'll do is, we'll do one thing, we'll make this more interesting. I think it is still here. Okay, so what I'm gonna do is, let's like, bully ChatGPT. Let's ask this question. Oh, sorry. So what I'm gonna do is description. I'm gonna copy this and give the same question to ChatGPT. Okay, let's see what it gives actually. Give the solution for this LeetCode question. Who asked this, man? Now you're coming on to the point. Okay. So I'm gonna copy these. Let's see if it is working first. Okay, I think it should work, but I'm not like very sure of it. I hope it is correct actually. I'll try to run it. Just give me a minute. Let's see. Okay, so what let's do is, like, for better not confusing, we'll copy this completely and we'll put it there. Let's see if it is working actually. Okay, what code completely, right? Here it is. And now one tab. Probably now this should work. Let's see. Man, it is not working. I'm not gonna try again. So like, simply it is not that good. I'll just conclude it. Like, see, we did the same with Llama 2 as well. It gave correct result, right? So I'm not gonna try again. It is not giving good result according to me. Okay, but you can let me know. You can probably try and let me know, but I'm not gonna try again. So I'll conclude that this is better than this with this question alone. Okay, because like, I also tried with one or two questions, other questions. It is very easy question, like, but it gave good result, I'll say. But I didn't expect this result for that hard question. So we can say it is true, it is very good in coding. But again, that is with LeetCode questions. Probably with real case, it might differ. And we'll also try that, like, probably we can say, like, build a snake game, something like that. And probably it might work, So right now, since we know it is very good model, the testing is also completed. We'll see how we can fine tune it. So for this, I'm going to use Unsloth because it is a very big model. We need to fine tune it. Unsloth is faster to fine tune. Soon I'll make a course on Unsloth and let's see. And by the way, guys, there is an important announcement. In this video, I'll just go a walkthrough for this code, and soon another video will come where I'll explain this code each and every bit. But for that, I need to understand what is going on in here actually. There is parallelism involved in here. For this, I'll be walking through the code, like understanding the code actually first. And members will have a separate live for that. Like, we'll explore this code together. It will be a long process, so it will be a live. And probably once that is done and I've prepared for the video, right? A video will come explaining a walkthrough for this code that will be available for everyone. That is an important announcement I wanted to make. So now let's see about fine tuning. Okay. So here they are getting the torch divides capability. Like, what version is this CUDA? Is it like newer GPUs or older GPUs? We are using an older GPU, so here it will install these. Okay, Xformers. This is what is the core actually, which will be slightly faster, and TRL for the trainer, PEFT for like LoRa config, accelerate, bits and bytes. All are conventional imports. And then we are also installing Unsloth Colab new because they have said they can increase the training performance when you like specify one parameter known as gradient checkpointing to Unsloth. If you said that, like, it will be very fast is what they claimed recently in Twitter. So that's why they have released a new version known as Unsloth Colab new. Okay, you can run these, it is working. Okay, but I'm not going to run now. This is just walkthrough of the code. So here we are importing the fast language model, which will, like, wrap the Hugging Face model with a wrapper, this is what makes it faster. Okay, so here they have itself quantized it to 4-bit and it is available. But if you want to use the original model, you can just go to Llama 3 in Hugging Face. Just type Llama 3. Right now I have access, but I'm expecting you guys to not have access actually, because I applied for access. You can just give your values here, like you can just fill the form. I'll show you how you can do that as well. You can just go, no need to read a lot actually. So what you can do is just do a login. If I do login now, I'll have reports. So once you do login, you will get your access to this model. But there are some people who have uploaded the HF version as well, so probably you can use that without even access. But it is better if you use the original repo or repo from Unsloth. Okay, so here I'm gonna use the Unsloth's bits and bytes 4-bit quantized model, and the max sequence length is set to 512. Okay, they are loading it in 4-bit, so it is loaded in 4-bit. If we run this, and then next what we'll do is we'll attach the LoRa modules to it. So the rank is 16. We are having the modules, the same module. They didn't change the value name at all. Q proj, K proj, V proj, O proj, all are for attention. Gate proj, up proj, down proj for MLP. Query key value, output projection, up projection, down projection, and gate projection. Okay, and LoRa alpha is 16. LoRa dropout is 0. Bias is none. This is what makes it faster. Use gradient checkpointing. Set it to Unsloth. Okay. You can give a random state if you want. If not, just comment it. Same for RS LoRa and LoftQ config. Comment it if you do if you are gonna fine tune like me. But if you are gonna use RS LoRa and LoftQ config, you might need to set the values. So for this, what I'm gonna do is I'm gonna fine tune this on Alpaca cleaned dataset. This is a chat dataset. Okay, that is available in Hugging Face itself. I'll show you now. I'll zoom out a bit. Here you can see it is there, right? There is input, instruction, and output. So it will be like instruction, input, output. That's how we'll set it. Okay. So here you can see, right? Instruction, input, response. So, you can also do it like this actually. Just put input. You can just have all of these commented. Just put input there, comment all of these and put input there. That's all. Okay. That is also possible, but it's upon you. Okay. Like to do what you want. So what I would have done here is, take all of these, put it in here, and I'll also add an EOS token. Okay, tokenizer EOS token. For example, it is \yes, something like that. It is very important because, like if you don't add it, the generation will go on and on forever. So it is very important you do that. So what it will happen is it will just try to, format the string. This is F string. Okay, it will format the string, and all of these will be put in a single column known as text, because whenever you use SFT trainer, it is expected that all of the data is available in one column, which is text column or whatever column upon your choice, but it should be in one column. Okay, so that's what we are going to see now. SFT trainer, and in this we are providing the model tokenizer dataset which we fine-tuned now or created now, and text is the column which I gave here. You can also give your own column name upon your choice. Max sequence length we have already provided 512. Dataset num process 2, which means 2 processor will be used for tokenization and creating of this prompt and all everything. And packing will be false. Okay, packing is short sequences will be combined together for one long sequence of 512, but you can also use short sequence itself. So let's say packing is equal to false. Now coming on to the training arguments, batch size is 2 and gradient accumulation steps is 4, which means at 8 steps or 8 data once back propagation will happen. Okay, and warm-up steps is 10, max steps is 100. Again, this is experimentation purpose, so I have kept the warm-up steps to 100, but if you want to fine-tune for your own custom use case, just comment it out like this. Okay, and learning rate is 2E-4. We are checking if BF16 is supported, which won't be the case with Colab GPUs, but if you're using a bigger GPU like latest GPU, something like A100, H100 or something like that, you'll be having BF16 supported. So what will happen is BF16 will be enabled, but here in this case FP16 will be enabled. Okay, and since we are using quantized, we are following a QLoRa method, which again tells us to use the optimizer RMW 8-bit, and learning rate scheduler type is linear, and output directory is outputs. If you wanna put it, you can put it in outputs directory or whatever directory of your own choice. So since the trainer is ready, you can just call the trainer or train function. It will train. I just ran it for 10 like 100 steps. It was converging actually. Okay, it from 1.67 it went to 0.977. With correct fine tuning for a longer time, it should do good, because we have seen the potential now, right? So once you are done with the fine tuning, you can save that with this code. Like, you can just push this to the hub, which will just push the adapters, not the model. So to push it along with the model, you should call the push to hub merged, which will like push this model to the original one. And in save method, you can also put merged 4-bit, which will like combine this LoRa to 4-bit model. Usually it is not like suggested to combine with the 4-bit model. That is not suggested actually. Okay, so you can run that, and then if you run this for inference, like if you set this for inference, right, it is said that you will get 2x faster inference, and it gave a good result actually. So when I gave since it is a chat data, I was expecting it to give some chat actually, and it did well actually. When I say like 1 2 3 5 8 complete this, it said like next is 13, and why is that 1 is there, and then next will be added, and it stopped, like see. So there should be some explanation to it, and since I gave just 64 token, it was not able to say. And if you want to put it in a GGF format so that you can use in VLLM, Llama CPP, C transformer, or Llama, whatever it is, you can just also save it using save pretrained GGF and give your own quantization method upon your choice. Okay, so that is how you can fine tune, save, and infer your model. But this is just normal inference. Like I said, still we have a lot of things pending in this video. We have seen what is Llama 3, why it is working well with, again, my assumption, and then it's fine tuning, it's inference, base inference, everything is done. But we also need to see another thing, which is how they did some safe inference here. So what I'm going to do is, see here, in Llama 3, this is the official Llama 3 GitHub repo. And here there is this one thing. Let's go into Llama. I think it is Llama recipes. Let's see where it is actually. Yeah, here it is. Okay. If you click this Llama recipes, here in recipes, I guess, inference, local inference. Here it is. Yes. See here. They are doing some safety check and all. Okay. I'll do all of these exploration in live with members. Don't worry. And again, don't worry guys, if you are even just subscribed or not even subscribed, you're wanting to just know from me, still you will also get the video. Probably it will be later because I won't explore this in live. I'll explore with them, and then I'll make a video out of this and put a video like this very soon. As soon as possible, it will be done. Okay. So this is the official repo, and here you can see, right, they are doing some safety check and all, which will do a safety check before and after. Both will be done. Okay. That's what they showed in the official repo. So I'm expecting that to happen. So here what I'm going to do is I'm just going to show you all that data is the thing which made this unique, not the architecture. Okay. RMS norm, not very unique. It is always there. Okay. In attention, they are using parallelism, but still the attention is not new. Okay. They are using KV caching here. Okay. And there is other than that, there is nothing new. It is group query attention. Okay. In feed forward, it is normal. Like they are using silu attention function. Sorry, activation function. And again, yeah, you can try with other attention function as well. Sorry, activation function as well. Like sweglue, jglue. Glue activation function are said to be like very good actually. So you can also try that. And then they are building a transformer block out of it, where what they're doing is they'll first normalize the input, and that will be provided for attention, and then there will be again a normalization of this. It will be added with the input, and then now what will happen is probably we shall see how architecture is. Okay, I'm not going to explain the multi-group query attention at all, because I've already did that in the Mistral architecture explanation video. So now what I'm going to do is I'm going to show you the flow of this architecture, how this architecture will look like if you put this architecture diagram like in the attention is all you need paper. Okay, so let's do that. I hope that will be like, something which is useful for you all. So what I'm going to do is, let me open Epic Pen. Where is it? Yeah, here it is. Let's take yellow. It will write here. So given an input, let's consider that, the safety guard and all is completed. Okay. Or even let's put it at safety. So given your input, the safety guard is done and the input will be reformatted. Again, it will be tokenized. Everything will be done. Let's say everything is done and reformatted itself. Okay. Next, what happens is it will go into the transformer block, which will be something like here. And in here first, it will do a normalization, RMS norm, and then it will go into attention. Okay. And this input, okay, will be added here. Okay. This, once it is done, it is again normalized, sent into a feed forward, and these two are added. This is how the architecture is. Now say, there is nothing new in here, right? See, this is multi-query, group query attention, and the norm is RMS norm. That's all. Nothing new here. Okay. The activation function is still here. Again, that is not something new. Why they did well? Again, that's why I said my assumption is data. Data is what made them very good like this, what they are right now. But I don't know, I don't know if I'm right, but I heard from them that it will be an AGI or something like that. I think Zuckerberg made an interview like that, but I don't see any AGI here. But probably this could be a step, because they are focusing more on reasoning, and once a model does reasoning very well, that is always a very good step towards AGI. Okay, so I'll say they are not doing walk the talk, they are trying to do what they said they will do. Okay, something like that you can put it. And now the transformer block is constructed, and this will be replicated for num layers, whatever you have. And then finally there is a projection layer here, output layer. Okay, so this is what happens in the Llama in a brief way. Okay, Llama 3 architecture in a brief way. We need to see what is this parallelism. This is an old library from Fairscale, which is again from them itself. I didn't know something like this existed actually. Today only I knew that this was existing. And here you can see they are doing some parallelism. And yeah, probably very soon I'll show you how you can pre-train Llama 3. Okay, let's do that as well. Let me know if you want that. Let me know in the comment section. I'll also make a video of how you can pre-train an architecture like Llama 3, implement it from scratch and all. Okay, so yeah guys, this was your Llama all you need to know guide, where I showed how you can fine tune it, inference it. We showed some real testing, and then we also saw why it is good, why it is the next level model. Everything we saw, why it is even better than Mistral, probably the best model right now in the open source environment. So yeah, I'll say it was a pretty good model. Okay, but it has long ways to go. Again, this is another step. Like Llama 2 was released, then Mistral was released, now Llama 3. Again, always there will be a model to beat, but right now Llama 3 is the best model, and I hope it stays to be the best model by improving itself. With that being said, if you all like this video, please hit the like button, share it with your friends, and let me know your thoughts in the comment section. I'll see you all in the next video, guys. Until then, cheers.